We're going to show you how to make a battery out of lemons, galvanized nails, copper pennies, copper wire, LEDs, wire cutters, and just to check the voltage that we're getting out of the lemon batteries, we're going to use a multimeter. Now, a disclaimer, why do we need to use galvanized nails? Because the galvanized nails are basically iron nails. These are iron nails covered with zinc. The zinc is what we need to donate the electrons, to the copper, which means that there's going to be electron flow, which means that there's going to be a current, and hence a circuit that outputs that can output energy, which is like a battery, basically. Now, we're gonna start by making just one battery out of one lemon, and then we're gonna build a battery out of three battery cells, and try to light up blue LED. The blue LED basically needs a minimum amount of voltage, but not much current, which is ideal because the lemons don't output much current, but they do have a significant amount of voltage. Now we're going to start with placing the penny in. In order to place the penny, we need to make some holes in the lemon using some copper pennies. Using the iron nail. Now just insert the penny. We have to insert it as much as possible because if we expose more of the copper penny into the lemon, the electrolyte, which is basically the one that's transferring the electrons from the iron nail to the copper, is going to have more electrons to transfer, therefore more voltage. And I'm going to explain everything about voltage, electrons transfer, current, on a whiteboard. Now we just need to see how much voltage we're getting. As you can see here, we're getting a lot of voltage. We can get, if we push it down a little bit, we can get 9.5, hopefully. Come on. Alright, it's not feeling like 9.5 right now, but the maximum this lemon battery will get us is 9.5. Now, it's negative here because of something called current, difference between current and electron flow. Electron flow is the transfer of electrons from the positive to the negative. In the actual circuit world, we have the convention of current. Current is the transfer of electrons from on the opposite direction of the flow of electrons. This is just a convention because they used to think that electrons are positive, so they are attracted from the positive, they're repelled from the positive end and attracted to the negative end. But in actual fact, they're negative, so they're attracted to the negative end, and they're attracted to the positive end, and they're repelled from the negative end. Here, so the electron flows in a direction. Here, the current, the voltage is positive in the opposite direction of electron flow. So from here to here. This is from positive to negative, and the electron flows from positive to negative. This is from negative to positive. So opposite direction. So we're getting 9.2. So to light up the LED, we need at least 2.9 or 3. Because the ideal conditions are 3.4 volts and 20 milliamps. We don't have 20 milliamps, and we can do with 2.9. So it's gonna work if we have series voltage. So we add voltage from one battery cell to the other in order to get 0.9 times 3, which is around 2.8, 2.75, whatever we get. So we're gonna make a battery out of 3 battery cells in order to get the amount of voltage to light up an LED. And we're gonna connect them using the copper wire. This is 0.6 millimeter copper wire. You can get it from Amazon. I got it in the UK from Amazon. You can get this from eBay. I got it in the UK from eBay, but you can probably get it in the USA, anywhere that has eBay or Amazon or whatever electronic store that you have in your local area. So in order to connect the batteries, we need to connect the positive end to the negative end. So because the electron flow is from positive to negative, positive to negative, positive to negative, we connect the positive to the negative, to the positive to the negative, to positive to negative. So we connect the current from the positive end from the negative end to the positive end, and we're gonna put a copper penny here, and then we're gonna connect it to iron, and you get the idea. Just make 3 holes. And we just insert the copper penny. We connect so this is quite malleable, so it's relatively easy to handle. You just have to basically loop the copper wire around the iron nail. I mean, yeah, it's the galvanized nail, but it's made of iron, and connect the negative end to the positive end of another element of the other battery cell, and we make another battery cell right here. So we just need to make a hole for the iron nail, and make 3 holes to insert the copper penny. Get as much of it in as possible, and we got it in there. And we need to get more wire just to connect it up. So just loop it around. And we need the copper wire to transfer the electrons from one battery cell to the other and the other, so that we have a connected circuit, and the voltage can add up in series using the battery cells. And we get, hopefully, we're gonna measure the voltage now out of the 3, and we should get. So we want to get we should get around. Oh, okay. Hold on. Let me just glance it. Yeah, we're getting 2.8 volts. Okay. Let me see if I can try to. That's just making it worse. Okay, great. Okay, so we need a little more copper wire. If you get 10 meters of copper wire, you're gonna have plenty of copper wire to have a whole class make these lemon batteries. I'm actually using excess right now, but it's okay. Other clamps. We're gonna get more copper wire to connect the positive end, or in this case, actually the negative end, because of current and electron flow convention. So you have to try to make it straight and then just bend it around. Okay. Hopefully that's it's not sturdy. That's right. All right. Now we're gonna get an LED. Now the LED convention is the longer leg is the positive end and the shorter leg is the negative end. So we take this part, as you can see, here we got some light. Great. Now we get to the case of how do we get more light out of this one LED. Now we have a series battery cell. So this gives us like 2.8 volts, which is enough to light up the LED, but not very brightly. To light it up a little more brightly, to get more illumination out of it, we need to be able to supply more current to the LED, because it's the ideal conditions, and this lights up really brightly under ideal conditions, which is 20 milliamps and 3.4 volts. Here, if we try to measure the current, I'm gonna try to measure the current right now. We don't actually get a reading. Or we might get a reading, but it's very, very small. Yeah, we got it at DC current 200 micro. You don't get a reading. Might be in the nanoamps. So, in order to increase the amount of current that we can supply to the LED, we use a parallel circuit. And basically, we're gonna have the same exact form of batteries of a battery, but the same another battery in another row, in line with the same format. But we're gonna take the current and electrons from both batteries and supply it to the LED. Okay, so let's do that with 3 more. Right, so put it in the side. And you can actually make like 4 in row by row, because we have enough. We have a lot of a lot of juice, lemon juice inside of this plump lemon. So it can the electrolyte can support the transfer electrons inside this circuit. So we just put 3. Just make another hole. We make holes for the third the copper pennies. One, 2, 3. 1, 2, 3, and put it in. Put it in. Put it in. Does get kind of messy because the lemon juice just fills up. So I have some tissues at hand. Right, So we're gonna cut the copper wire right now. Just try. Right, just connect it up. Okay. Actually, I'm gonna try something differently and wind it round before I put it in. There we go, that's easier. And now I'm just gonna wind it around this end to get, wait, no. So maybe. Actually, it doesn't really matter, but no, it doesn't really matter. Okay, we're gonna have to get. Actually, I'm gonna cut this in half because we're wasting too much copper. Right. All right. And we just need to wind this up. Right, and we get this LED, moment of truth. As you can see, it's a little brighter. There we go. Bright.